now let us start with a few examples. Let us look at this question. Again, this was a question that was asked in one of the JEE Mains previous year papers. Let the abscissa of 2 points P and Q. I hope you all know what is the meaning of abscissa. Abscissa means the x coordinate. And I hope you know what the y coordinate is known as. It is known as ordinates. Here they have mentioned here. So let the abscissa of 2 points P and Q be roots of this equation and the ordinates of P and Q be the roots of this equation. If the equation of the circle described on PQ as diameter is this, then we have to find out the value of basically RS, Q and P. So let's look at the first equation that has been provided to us. So let me first draw a circle. So they have told us that this is a circle. There is a diameter that passes in the circle. PQ is the diameter. P has, let us assume the points to be x1 comma y1, and for Q let us assume it to be x2 comma y2. Now they have told us that x1 and x2 are the roots of this equation. That means 2x square minus rx plus p is equals to 0. The roots of this equation are x1 and x2. So from this, what can we tell about x1 and x2? I hope you all remember we had studied this in quadratic equation. The sum of roots can be written as minus b by a. And what is here b? B is minus r, so minus and minus gets cancelled, so we get r by 2. And the product of roots x1, x2, this used to be c by a. Here the value of c is p and a is 2. So this is one of the equations about the abscissa that we've gotten. Now let us find out for the other one as well. The ordinates y1 and y2 are roots of this equation. So let us do the same for that. X square minus sx minus q is equals to 0. So from here we know the roots are y1 and y2. That means y1 plus y2 is equal to minus b by a. So this becomes s. A is 1 here, so it's simply just s, and y1 y2 the product becomes c by a, so minus q. So this is another equations that we've gotten. Now we know that since the 2 points of the diameter have been provided to us, 2 endpoints of the diameter, we know how we can write the equation of a circle. We had studied this. That means circle's equation in diametric form. What used to be the formula? It used to be x minus x1 into x minus x2 plus y minus y1 into y minus y2. This is equals to 0. This used to be the equation of diametric form. So let us try to open both these equations. What are we going to get? And try to convert it in such a format that we have x1 plus x2 in there, x1 x2 there, y1 plus y2 there, and y1 y2 there, so that we can simply just replace the values and we can compare it with this equation. Of course, this is the equation of the circle that has been provided to us. So let us try to transform this. What are we going to get? We are going to get x square minus x, this would become x1 plus x2 plus x1 x2, and from here we are going to get y square minus y, same thing, y1 plus y2 plus y1 y2. This would be equal to 0. So now let us replace the values of x1 plus x2, x1 x2, y1 plus y2 and y1 y2. So what do we get after that? X square minus x1 plus x2 is r by 2 minus r by 2x plus x1 x2 is p by 2 plus y square minus y1 plus y2 is s minus sy, and y1 y2 is minus q, so minus q. This is equal to 0. So let us take 2 as LCM and let us cross multiply it. Let us remove it from the denominator sign. So what are we going to get? 2x square minus rx plus p plus 2y square minus 2sy minus 2q is equals to 0. Now let us try to transform this into the form that has been given to us in the question. Let us write the form given in the question here. They have given us 2x square plus y square minus 11x minus 14y minus 22 is equals to 0. So this is given into us in the question. So let us try to form this equation that we found out in this manner, so that we can simply compare and find out the values of r, p, s and q. So from here, what do we get? 2, if I take common, we are going to get x square plus y square, as it has been given in this one, minus rx minus 2 sy, so plus p minus 2q is equals to 0. So this is what we are getting. So basically from here, if we compare these two equations, what are we going to get? R can be written as 11. Our S, of course, 2s is equal to 14. That means s would be equal to 7. And p minus 2q, the constant terms, if we match them, what are we getting? Minus 22. That means 2q minus p is equals to 22. Now let us see what has been asked to us in the question. They've asked us to find out 2r plus s minus 2q plus p. So from here, let us put the values that we've just gotten. 2r, r is 11, that means 2r would become 22, plus s is 7, so we can simply put 7, minus 2q plus p, and that is minus 22. So minus 22 comes here. So from here, what are we getting? Simply just 7, and this is our answer. So this was again a very easy question that was asked. The only thing is that you had to remember this concept of quadratic equation, the roots, how they are found out, the sum of roots and the product of roots. Let's look at another question. The number of integral values of lambda for which x square plus y square plus lambda x plus 1 minus lambda y plus 5 is the equation of a circle whose radius cannot exceed 5. That means they've given us in the question that the radius is always less than or equal to 5. It cannot exceed 5. So let us first write down the equation of the circle that has been given to us. 1 minus lambda y plus 5 is equals to 0. Now let us compare this with the standard form that we had studied. What was the standard form? X square plus y square plus 2gx plus 2fy plus c is equals to 0. This used to be our standard form. And what used to be the center? Center used to be minus g comma minus f, and our radius was written as g square plus f square minus c. I hope you all remember this. We had studied this in the previous lecture in the theory format. So now let us compare this with this equation and find out what the center is going to be. So first let us find out what is the g value for this equation. For this equation, our g plus 2gx, that means our g would be lambda by 2, and our f would become 1 minus lambda by 2. And what would be our c? C is equal to 5. So now let us find out the center. Center is minus lambda by 2, comma, lambda minus 1 by 2. I have taken the minus common and put it here. So this is our center. So if we know that this is our minus g, this is our minus f. So let us find out what our radius would be. Root under g square, this would become lambda square by 4 plus f square, lambda minus 1 whole square by 4 minus c, minus 5. So this is our radius, and they've told us that radius is always less than or equal to 5. So we have to basically solve this equation, try to find out what are the values of lambda that would satisfy this equation. Of course, we know that radius would always be greater than equal to 0. So we can write one more equation here so that there is a limit set. And based on this, we have to find out what the number of integral values of lambda that would satisfy this equation. So now let us get into solving the equation. So what do we get here? Under the root we have, if we take 4 common, what are we going to get? Lambda square plus 1 minus 2 lambda minus 20 upon 4. This is less than equal to 5 and this is greater than equal to 0. Let us try to solve this equation. Let us square all the sides, so we get 0 less than equal to 2 lambda square minus 2 lambda minus 19 by 4 is less than equal to 25. So let us cross multiply 4, we get 0 less than 2 lambda square minus 2 lambda minus 19 is less than equal to 100. Let us take the 100, or let us take the 100 to one of the sides. What are we going to get? 2 lambda square minus 2 lambda, and here we are going to get, this would become minus 119 less than equal to 0. So this is the equation that we are getting. So from here we can simply just solve this quadratic equation. We can say that lambda would be equal to minus b plus minus root under b square minus 4ac upon 2a. We can use that formula. So lambda would be equal to minus b plus minus root under b square minus 4ac. B square is 4, minus into minus becomes plus, plus 4 2s are 8, 8 into 119 plus 4, this would give us 239 by 2a. So this is our lambda. So basically what we are saying is that our lambda lies from 2 plus root under 239 by 4 up till 2 plus root under 239 by 4. Sorry, this is minus. Sorry, there is a multiply 4 here as well, so that is left out. So if we take 4 common here, so we would be left with just 2 here, and this would become into 1. Again 4, if we take it out, this is into 4 here, sorry. So this would be 2 and this would be 1. Sorry for that. There would be a 4 multiplied as here as well, because 4ac, I just missed out the 4 while calculating. So there would, so this is what we would get, the values of lambda. Now of course it is not possible for us to find out the exact value of lambda. So let us try to find out the approximate range in which lambda would lie. So let us try to find out what root 239 would be. So how can we find out root under 239? We know that root under 225 is equal to 15, and we know that root under 256, this is our 16. We know these values. So that means 239 is lying somewhere in between these two values. That means the root of 239 would be 15 point something something. Of course, we are not taking the exact values. We are just trying to find out the approximate value. 239 would be, of course, 15 point something something. So let us put 15 point, let us assume 15 point something something in both these equation and find out what lambda would lie from. So if I put 15 point something from here to here, so this would become 1 plus 15 point something something, this would make it 16 point something something, divided by 2 would make it 8 point something something. And here, if let's say again I put 15 point something minus, there is a 1 here, so it would become minus 14 point something something divided by 2, so we would get minus 7 point something something. So basically the range of lambda is lying from minus 7 point something something to 8 point something something. So let us see what was asked to us in the question. The question had asked us to find out the number of integral values of lambda. That means we just need to find out the integral values of lambda that are possible. Of course, we can see from here that minus 7 would be a possible value, since minus 7 is greater than this value. Minus 6 would be a possible value, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, and 8 would also be a possible value. 9 cannot be taken because the lambda is always less than 8 point something. So these are all the integral values that are possible for lambda. Now how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 values are there, and they had asked us the number of integral values. So our answer becomes 16. This is our answer. Again, a very easy question. You just needed to apply some basic concepts of circle. The only thing that was here was you had to use your logic to find out root under 239, that it would lie somewhere between 15 and 16, and then you could have found out the integral values of lambda. Let us look at another question. Now what has been given here? A circle touches both the y-axis and this line. Then the locus of its center is. Again, we have to find out the locus. So let us draw the diagram. The line that has been given to us is y is equals to minus x. Let us transform it into y is equals to mx plus c format. Now we can draw this line. Of course, this line passes through the origin and would look like somewhat this. The circle touches both the y-axis and this line. That means the circle can be here. Sorry. That means the circle can either be here. It touches both the y and this line. The circle can be here as well. The circle can be here. There can be a lot of circles. It can either be here, here, or the circle can be in this format as well. I hope you are understanding it is touching the y-axis as well as this line here. So there can be a lot of circles. So let us take just a general one, simple one. And I hope you all remember the concept of locus that we had studied in straight line. We have to find out the locus of its center. So we assume the center to be h comma k. And once we've found out an equation which is based on h and k, we can replace h with x and k with y. And that would be our locus. So from here, what do we know? That since it touches the y-axis, that means this length is our h. This length. Of course, I'm taking just the magnitude here. If you were to look at this, this would of course be minus h here, minus h comma k. So let us just assume that this length would be h. That means what my radius for this type of circle becomes. Radius is equal to h. And I can say this is also my radius. And what else can I say about this? That this is a point C and this is, let's say, a straight line. Of course, this is the foot of perpendicular. That means the perpendicular line, perpendicular distance of a point from a line. We had studied this in straight line. The distance we know how we can find out. We know the equation of this line to be x plus y is equals to 0. We know the point is minus h comma k. We can simply use our distance formula to find out this distance, which is nothing but our r. So let us use that formula. So now let us use that distance formula. What are we going to get? R would be equal to, we have to put this point on this line. So we get minus h plus k upon root under 1 square plus 1 square makes it 2. So R is equal to minus h plus k by root 2. And we have also studied that since it touches the y-axis, our R is also equal to h. That means we can simply replace r by h and this would be minus h plus k upon root 2. Now I hope you all can see that in this equation there are only h and k terms. So simply we can replace h with x and k with y to get our locus. So let us just simplify this so that we can remove the mod. Let us square both the sides. We would get 2h square is equals to h square plus k square minus 2hk. And from here, if I replace h and k with x and y, we would get x square equal to y square minus 2xy. So this is our equation of the circle that we found out. Sorry, the locus of the centers that would touch both the y-axis and the line x plus y is equals to 0. So this is our answer. Now again, you could have simply otherwise, let's say instead of, there could have been another possibility here. Instead of minus h comma k, let's say if you would have taken the point somewhere here, it would be h comma k. Now you have to consider this possibility as well here to find out basically the sign. So you would have taken, of course, positive h and positive k. So that time r would have been equal to mod of h plus k upon root 2. And using this formula, you would have gotten the equation to be this one plus 2xy. Now again, both these equations are correct. Both these equations are the locus of our circle. Locus of the center that we are trying to find out. So again, it could have been in both ways. Let's say in the option, if this, while in the options in the question, this option would not have been present. That means you would have to answer this option. So this is how generally you find out the locus. Let us now look at another concept in circles, intercepts made by a circle. So of course I've told you a bit about the intercepts. Let's say there is a circle. Now you can see that the intercept that it makes on the y-axis, this length, and this is the length of the intercept that it makes in the x-axis. So this is, let's say, L, this is, let's say this is Ly, this is Lx. So we can find out the length of intercept it makes on the x-axis as well as the y-axis. Simply formulas. Again, you can I'm not going to get into the derivation of finding out the length of x-intercept and y-intercept. It is in the syllabus of JEE Advanced. However, I will still just give you a brief overview. Let's say this is our circle, this is our x-axis, and I'm trying to find out the x-intercept. This is my center. I hope you all remember I had taught you in the properties section that if I drop a perpendicular, then this line is always equal to this line. I know these points, what these points are on the x-axis. I can simply find out using the midpoint formula this point and then find out the distance. So that is how I find out generally the length of x-intercept. So again, these are things that you need to remember. Apart from this, there is an important thing that you need to remember here is that whenever in a circle, any line, let's say, passes through the circle and it is based on intercepts, let's say. So you simply just find out the distance, this distance, and you can connect these two lines as well. This becomes our radius. I hope you are understanding why this is our radius. And since this is a 90-degree right angle triangle that we are forming, so we can say that r square would be equal to, if let's say this is d and this is, let's say, L by 2, because this entire length is L and both intercepts are equal, so I can say this is L by 2. So r square can be written as d square plus L square by 4. This is an important concept that you need to understand how I am coming to this solution. Of course, whenever you connect any point on the circumference with the center, this would be equal to radius, and we know that the foot of perpendicular of the center on the intercept line divides that intercept into two equal halves. So if the entire intercept's length is L, so just the half would become L by 2, and this distance we can calculate it using our distance formula that we had studied in straight line. So from here we can say, using our Pythagoras theorem, we can find out r is square. Apart from that, the length of x-intercept and y-intercept, if the circle intersects the x and y-axis, simply formulas, they are present. Again, I'm not getting into the derivation. Of course, you can try it out by yourself using these concepts that I just taught you. You can find out the lengths, and for JEE Mains you just need to remember the formulas. It will be enough for you. So let us look at a question about finding out intercepts first. Two circles in the first quadrant of radii r1 and r2 touch the coordinate axis. Each of them cut off an intercept of length 2 units with the line x plus y is equals to 2. Then we have to find out r1 and r2 basically. So let us draw the diagram. Of course, since it is in the first quadrant, our circle touches the coordinate axis. That means our circle is in this format. Let's say it touches the x axis as well as it touches the y axis. So let's say if this length is a, then this length would also become a. Our center is nothing but a comma a. Again, I'm just considering one circle for instance, and then later on we can check it for both r1 and r2. And this is my line somewhat. This is my x plus y is equals to 2. Now from the center, of course, I can drop a perpendicular, and this would divide this line into two equal halves, and we know that the length of this intercept is 2 units. It has been given in the question. That means this length is 1 and this length is 1. So if I connect it, we know that the radius of this circle is also equal to a. We had learned this in special cases of circles, that when a circle touches both the coordinate axis, its center becomes a comma a and its radius is also equal to a. So this is also a. So since we know the center, we know the equation of this line, we can find out this distance. And once we find out this distance d, we can use Pythagoras theorem with d, 1 and a, since it is a right angle triangle. Of course, a square would be equal to d square plus 1 square. So a square would be equal to d square plus 1. We can use this to find out our A. And again, I hope you all can see that A would be forming a quadratic when we find out D as well. So there would be two values of A that we would be getting. So those two values would be our R1 and R2. So let us try to solve this one. Let us find out D using our straight line formula. D would be equal to modulus of x plus y minus 2. This is our equation of the line. Of course, I hope you all remember we used to find out L. L used to be x plus y minus 2. I hope you all remember what L1 also used to be, where we put the point in the equation of the line. That is what we call as L1. L1 used to be a constant. So here we put L1 here, and our point is a comma a. So we put a plus a minus 2 upon root under 2. So this is our D. Now let us put this value of D in this equation. What are we going to get then? So let us simplify D a little bit more. This would give us 2 common outside, a minus 1 upon root 2. Root 2 would cancel this root 2 times, and let us substitute D there in that equation. We get a square is equals to D square. So 2 a square plus 1 minus 2a plus 1. So from here, a square is equals to 2a square plus 2 minus 4a plus 1. From here, what are we getting? A square minus 4a plus 3 is equals to 0. So this is our equation that we've gotten. And what are the values of a that would satisfy this equation? A minus 3 seems to be one of them, and a minus 1 if we factorize it. So basically, what are the values of a that we are getting? It is either 3 or a is equal to 1. And what is our a? A is nothing but our radius and the center of this circle. So our radius basically becomes R1 is equals to 1 and R2 is equals to 3. So we've gotten R1 and R2, and that was exactly what was asked to us in the question. We had to find out R1 square plus R2 square minus R1 R2. R1 square plus R2 square minus R1 R2. So let us put the values here. What are we going to get? 9 plus 1 minus 3. We get 7 as our answer. Again, a question that was asked in one of the JEE mains. Again, you had to remember what the special case of a circle would look like, and this concept of intercept of circle, that you can form a right angle triangle and you can apply Pythagoras theorem. And this is also another important concept that you must remember, is that the line, the perpendicular that we draw from the center on the intercept line, it divides basically the intercept in two equal halves. So since the entire length was 2, this point, let's say m point divided the intercept into two equal halves, which was 1 and 1. And from there, applying Pythagoras theorem and our point straight line distance formula, we were able to calculate our value of a, R1 and R2 basically. So now this was the end of the first portion of the chapter. Now we will be looking into the position of points, position of lines, and then a few more topics about the chords of circle.